Hi everyone.
Hello, sir.
Yeah, hi Simis, hi Zipra. How are you?
Yeah, I'm fine, sir. Thank you.
I'm fine.
Okay. Any doubts you have on the previous topics?
Yes, sir.
Yeah, tell me.
Sir, last assignment you gave, I
Hmm.
want to ask, um, the data frame assignment you gave,
Yes, yes.
data frame employee.
Okay, let me check. And then sign it. Yeah, employee, right?
Yeah.
Tell me which questions you're not able to do.
Sir, I tried it, but first question is giving error.
Uh, Sort data frame imply in the ascending order of age. Okay. Can you paste me the code here? You have
Yes,
code
sir.
with you? Yeah, just paste this
Yes,
code
sir.
in this
Yes.
window. Yeah, here. Okay. So this is my which age? Age is not here. You have to add a age also.
Age.
First column is ID, second column is name, third
Okay.
column is age, 20 to 100, fourth column is sex, and fifth column is salary. Total five columns should be there. In
Yes, yes, sir. I'll see.
okay.
Number of rows is not same.
So here the number of rows not coming.
First one it has to be 25.
So you need to be 26 row. So here you take one extra. Okay. Now give the code for the sort. How we do the sorting?
What? Yes, sir.
Imply dot data order imply dot data dollar age comma. This is correct only. It's coming now.
Yes, sir.
Okay.
No, it's fine. It's fine. And sir, third question.
Okay. Descending order of salary for each group of six.
First question. It's the operations. First, third question. Data frame and three column. First column is date and second is product name. Third is city.
Company data, right?
Yes, yes.
First name is date values, product name, third column is city, Mumbai, Chennai, and Bangalore. It's correct only. We have done this one now. This complete data that you have here. So we have a date values, product name, and city name.
Okay, sir.
It's correct only. Okay.
Okay, sir.
Okay. So this is all about our assignments. Any doubts that you have, Siemens?
No, sir. Actually, I didn't try data frames till now.
Okay. Hmm. So today we're going to starting with your uh, a statistical method to find the relationship between the two variables, and we call it as a correlation. Okay. So your correlations is used to find relationship between two numeric variables. And this relationship will be identified with the help of a correlation coefficient that we denote by a letter r, a small letter r. The value of r will vary in the range of -1 to +1. If the value is negative, it is called as negative correlations. That means both the variables move into the opposite directions. And if the value is coming as positive, that is taken as a positive correlations, and in that case both the variables move in the same direction. Any example can you give, Sipra, for negative correlation?
Negative correlation.
Hmm? Think. Yeah, Siemens, can give some examples? For any positive correlation. Negative. Negative means you have identified two variables whose value is going to move into the opposite directions. If one increases, other should decrease. Take the example of a price and your demand. If a price of a product increases, of course people should start using less that particular product. Like suppose if you increase the price of tea, people start consuming less tea. So they start consuming less tea, that means the demand of the tea will be reduces. So more price, less demand, that have a negative correlation. What about positive correlations? Any example for that?
Height and weight.
Height and weight. with increasing height your weight will also increase. Yes, it's a good example. So height and weight is going to having a positive correlations. When the correlation values comes equal to 0, it is taken as a no correlations. That means the variables are not related to each other. Okay. There are 4 different methods are available to find the correlations. The default method we have is called Pearson correlations, which is also taken as default, and almost everywhere this method will be used. That is we call as Pearson correlations, and it is also a default and comes under the parametric method of your calculations. Parametric method means we are going to be using the mean and standard deviations to calculate the your Pearson correlations. Other methods that we have is called Hofding correlations, Spearman correlations, and Kendall correlations. In the case of R, you can find Pearson correlations, Spearman correlations, and Kendall correlations. Hofding is not present in the R. Now the questions come here: under what scenario which method will be used? In case you have continuous numeric variables. Continuous numeric variables are those numeric variables which has the decimal, and that values, if you want to find the correlations, we are going to be using the Pearson correlations. Anyhow, suppose it does not specify method names while calling the correlation functions, then they are going to be using the your Pearson correlations itself. If your data has ordinal values or a rank values, ordinal values are those values which can be used to arrange the data into a order, ascending or descending order, but we cannot say that how big or how small first value is there with respect to the second values. I mean, the difference between the values cannot be identified, but yes, we can say one is good, other is not good. Like customer's response or customer ranking for a service. So in that case, we are going to be giving the response of the customers as agree, strongly agree, neutral, then disagree, and strongly disagree. So we cannot say that the person who is strongly agree, how he is strongly agree, and the person who is agree. So we cannot find the difference between the agree and disagree, strongly agree. But yes, we can say those who are strongly agree means they are fully satisfied or fully happy with the service, whereas the agree one maybe have some scope of improvement or expecting something more in the improvement part. Okay, so that will be like called as ordinal data. Rank data are those data where a ranking has been assigned, and you can find the difference between the first values and second values. So the difference will be calculated, so you call as a rank data. And rank data can also be arranged into the ascending and descending orders. Only thing that difference can be calculated, so it's called as a rank data. So for ordinal and for rank data, we have to use a Spearman correlations, or you can use the Kendall correlations. Okay. Now when we go for the correlations, the data which we are going to be using, it is taken as a sample data. Means we are taking a part of the data for finding the correlations. Later on we have to see the your correlations for the population data.
Hello?
Yeah.
Yeah.
Can you hear me? Okay. Able to see my screen?
Yes.
Okay. So when the correlation that we find is taken as from the sample data, now on the sample data we have to test it for the population data. whether the correlations will exist for the populations or not. So that is called as your correlations hypothesis test. We check that correlation that we have calculated, that we have derived, is significant or not. For this case, we have a assumptions, and null assumption is nothing but called as null hypothesis. Null hypothesis, that will be assumptions made for the populations, and here your default, they have assumed that correlation is equal to 0. That means we represent here as RHO equal to 0, also called as rho equal to 0. Whereas another one we have is alternative hypothesis, where your opposite of null hypothesis is taken, will be taken here as correlation is not equal to 0. Not equal to 0 means it is significant. The assumption that we have made is significantly affecting my results. Okay. So here your test is considered as a significant if the p-values is coming here as less than or less than 0.05, or can say less than the confidence level. If correlation values comes less than the confidence level, we are going to taken as a not confidence level, significance level. So here if p-values is less than significance level, whose default value is 0.05, it is taken here as a your test is significant. Reasons, we are going to be rejecting the null hypothesis for p less than 0.05 and accepting the alternative hypothesis. You can say given here in the bold as well, if p is more than equal to 0.05, then accept H0, otherwise reject it. When we reject the null hypothesis, then we have to accept the alternative hypothesis. So we can write here as your test is significant if p value is less than 0.05, because we are going to accept alternative hypothesis. Let's see how to calculate these correlations and how to perform this correlation test. Okay. So to perform the correlation test, we require a data. I am using here a predefined data of a mass package. Under R installations, you will get around 32 package by default. Under this 32 package, mass is a one of them. So this mass package I am using here with the help of library, and this mass package has one data frame called cats. You can see on the right hand side, cat is now coming at the values. Want to see the value of cat, you can put here view cats, you can see the values of cat here. So this cat data set has 3 columns. First is your sex, second is your BWT. BWT stands for the body weight, SWT that is heart weight. I want to find a correlations between the BWT and SWT. Okay, any questions till now?
No, sir.
Sipra?
Yes, sir.
Okay, so let's see how to find these correlations. So before going for the correlations, I am seeing the structure of this data set. STR will give the structure of the data set. It has 144 observations, 3 variables. Sex is taken here as a factor because it has two unique values, F and M, and BWT and SWT are taken as a numeric values. And when we giving the summary, we will get a count for the sex F and M, and we'll get the 6 descriptive statistics for the your numeric values. So total in the given data set we have 47 female and 97 male, and BWT mean values is 2.72 and SWT mean values is 10.63. Your BWT is given in the kg and SWT is given in the grams. So before going for the your correlations finding, I just want to see what relations these two variables are holding. Graphically I want to see these relations. So we have a functions called plot which can give us a scatter plot between the given variables. So to use these plot functions, I am using here with cats, means for the cat data frame, plot BWT on the x-axis and SWT on the y-axis.
So width is a function.
Yeah, width is a function which will tell your R to take the given data frame. Okay, otherwise when we go for simply plot, they will going to search this BWT and SWT into the global environment. This BWT and SWT are a column of a data frame. They are not independent columns but a part of a data frame. So whenever we are using any column of a data frames, we have to use this with functions. Okay, you can see on the right hand side bottom. So you can see that the values are going from a low to towards high. That means as BWT increases, SWT is also increases. So if both variables move into the same direction, what that means? Positive correlations. So we are going to be expecting that BWT and SWT is going to have a positive correlations. Whenever we go for the correlations, we have to also categorize these correlations in terms of weak correlations, moderate correlations and strong correlations. So for this case what we can do, correlation correlation values and its meaning. So for this what we can do, I take mode of R. Mode of R means I am just seeing the positive values of the R. Even the negative and positive both going to come into the same range. So if the value of R is in the range of 0 to 0.3, it is taken here as weak correlation. 0.3 to 0.5 taken as moderate correlations. 0.5 to 1 is taken as strong correlations. Okay. Now if the values come as negative, we can say negative correlations, and if the value is going to come here in the range of minus 0 to minus 0.3, we can say here it is a negative weak correlations. Similarly, if the values come as positive and the value is coming in the range of 0.3 to 0.5, we can say positive moderate correlation. Okay, so R equal to minus 0.21, that means negative weak correlation. R equal to 0.46 positive moderate correlation. Okay, now on the basis of this we are going to be identifying what correlations exist between these two variables BWT and SWT. So to perform these correlations we have a functions called core. Core functions will give you the correlations between the your first variables and second variables. So with cat find correlations between BWT and SWT. So what value is coming here? See on the console.
It is strong positive.
Yes, so that means we have a positive correlations and it is taken here as a strong correlations. So we can write here positive strong correlations. Is it fine? Okay. You can even find the square of these correlations, that we call as the R square, which is nothing but we call as coefficient of determinant. That means to check how strong correlations exist. For that case we are going to take the your square values. So a square value is also coming here as a above 0.5, that means it is a strong positive correlations. What happens in the case of negative, people they find difficult to make an interpretation for this. So what they do, they take the square and then make a decision strong or a weak or a moderate correlation. Okay.
But suppose the correlation was 0.6, R value,
Okay.
then the R square will be 0.36.
No. This will
How
not.
should we interpret it?
It will not go so less. Will not be the half the. Will you close to the 0.5 only? If you take
I
here
think R is 0.6.
R equal to point
0.6.
0.6, right?
So R square will be, yeah,
If you find the R square,
R 0.36.
0.36 means coming here as a moderate.
All right.
Yeah.
So how should we interpret it? Because point 0.6 was higher.
Yeah, so that's the reasons when we're going for the 0.6 that is taken as a strong correlations, when we're going for the R square taken here as a moderate correlations. Still the values are coming in the acceptance regions only, means anything coming in the moderate to strong will be good enough to go for further analysis and all. Okay, when we go for the regressions and all, there we get the R square. Okay, so that times I'm going to explain to you how this R square is going to be playing the role and all.
Okay.
Okay. Next going to come here as, so this is regarding the correlations. Now will these correlations is enough for the making a decisions regarding the populations or not? So for this we are going to perform a correlation test to see how the population is going to behave. So what we are doing here, I am replacing these core functions with your core dot test. So with cat data frame core dot test bwt comma SWT. So see these results here. They giving here the Pearson's product moment correlations, and we are using the data of BWT and SWT to make a decisions regarding the acceptance or rejections of null hypothesis. Either you can use these t values and df, or you can make a decisions on the basis of p values. To make a decisions on the basis of t and df, that is degree of freedom, we require a t table. T table is a statistical tables which will be a predefined, just like a log tables that we have seen in the class 9 and 10. In the statistics we have many tables like normal distribution table, t table, f table, chi-square tables. So similarly t tables is also available. Okay, so when we have t tables with us, you can use the t tables and compare the t table value with your t that we are calculating it here. In case tables are not available, our decisions will be based on these p values. Now the p values coming here as 2.2 into e to power minus 16. That means the values coming here is very low, or say very less, or say equal to the 0 or tends to 0. E to power minus 16 means it's very small values. So it is very small values, that means it is coming here as less than 0.05. And what is the decisions we have to make if it is less than 0.05? See these Word documents. So if p value is more than 0.05, so just tell me the results, what is going to happen.
Test is significant.
Yes.
And we accept the alternate hypothesis.
Yes. So we are going to be accepting the alternative hypothesis and saying that your test is significant. Regions your p value is coming as very less, it is coming as less than 0.05, and your correlation is not coming as equal to 0 for the populations as well. So here also you can see a positive hypothesis coming here as correlation is not equal to 0, and this all this null hypothesis, alternative hypothesis, always going to work with your populations informations. Below that you can see I am getting here a confidence interval that will be indicating in what range your population correlations going to vary. Here values coming here as 95% confidence interval means if you perform a similar task with same number of observations out of 100 times, 95% chances that your correlations of your sample going to come in the range of 0.73 to 0.85. So your upper limits and lower limits means lower values and upper values both are coming in the your range of strong correlations. Okay, so your populations also indicates here there is a positive strong correlations between the BWT and SWT. And in the last they giving here the your sample estimates, that means the correlations for the sample data coming here at 0.804 which we have calculated. Okay,
But what is the difference again? Core and core test?
this
Would
p
you run
values,
it on the entire?
no, this p values, the p values is not known when we are going to be performing the core functions. Core dot test is going to be giving this p values. P value is very important.
Okay.
If this come as less than 0.05, then only we going to be using these correlations. If it exceed 0.05, that means correlation is not significant. We have to simply ignore these calculations and we go for some other set of variables. Okay, CPAT is fine for you. So interpretations here also I'm given here in the R code as well. Null hypothesis that be denoted by H0. Correlations is correlation does not exist between the variables. Rho equal to 0. Alternative that be denoted by your H1, and it is taken here as a correlations exist between the variables. It's taken here as a not equal to 0. Now we have in the null hypothesis testings and all, we are going to have the three different types of alternative hypothesis. One is correlations equal to not equal to 0, that currently we have seen here. Other is correlations greater than 0, and another one is correlations less than 0. So here in the case of R, we can decide the alternative hypothesis, that means for what values you are going to be testing, greater than 0, less than 0 or equal to 0. In case you does not specify anything, by default they taken here as a not equal to 0. Null hypothesis in all the cases are taken as equal to 0. Its alternative which will be changing. Is it fine?
Yes.
Now another point, whenever we see alternative hypothesis as correlations equal to 0, that means we are performing two-tail test. Two-tail test means if values are coming below the significance values, then also be going to reject the your null hypothesis. If values are coming here above that any significance levels, then also be going to be rejecting the null hypothesis. So that means we are going to have a two rejections regions when we putting here not equal to 0. Whenever we are going for a alternative greater than 0, that means we are performing a right tail test. When we putting alternative less than 0, that means we are performing left tail test. Now what the meaning of right tail and the left tail? Have you seen a bell-shaped curve?
Yes, sir.
Normal distribution curve is called as a bell-shaped curve, right? So in this 95% confidence intervals, we are seeing here these two values, 0.73 0.37 and 0.85, right? So 0.85 is the upper limits of your confidence interval, and 0.73 is your lower limits of the confidence intervals. If your sample data comes below this 0.73, then also be going to reject. If it comes above 0.85, then also be going to reject the sample data. So that we call as a your two-tailed test. But when we putting alternative greater than 0, that means we are going to be using only the your upper limits to compare. Lower limits will not be compared here. Okay. Similarly, when we go for less than, then the correlations derived will be compared with the lower limits, and upper limits will not be compared or not. So when you putting a greater, you will get only the upper confidence intervals values to compare the sample data or not. Okay. Here 95 is taken as a confidence level. So confidence level by default, or say ideally we always take here as a 95%. You can change these values by specifying the confidence level as a one of the argument of your for dot test functions. You can see I given here confidence level as 0.80. That means this 90% will change to the your 80%. So when your confidence level will change, the values that we are calculating here for upper limits or a lower limits will also going to change. Region your, I give you the formulas here. Confidence interval formula will be your mean, how we write the plus minus, will be your plus z into standard error, mean minus z into standard error. So here when you putting the plus, this is called as upper limit. Similarly, when you put in the minus, is taken here as lower limit. I make this as a comments. Okay. Now here you can see the mean and standard errors that will depend upon the your mean values and the standard of deviations and your number of observations, whereas Z will depend upon the your confidence level. For confidence level 0.95 or say 95%, your Z values is taken as 1.996. That we have to remember few values. For the calculations and all, we have to see the normal distributions table. I show you a normal distributions table and try to figure out the values. Can you see this image?
Yes.
So on the top you can see this is your normal distributions curve that is coming here now, where tail is not going to meet to the your axis, will keep going as till the infinity. Now you can see here this shaded regions is nothing but your going to give the probability of occurrence of the values, and 0 is representing here as a mean. Below means is negative, above means taken as a positive values, and this mean is going to come in the center of the curve, which will be representing the 50% of your probability. If you taking the mean as a 0, in that case we taking as a 0 probability or 0 z values. So at the mean, z is taken here as a 0. Now when we go for the confidence intervals as a confidence level as your 95%, that means we have a equal distributions of your observations across the mean. So 95% will be going to come as your 0.75 regions below the mean and 0.75 above the mean. So already you can see this graph showing here as shaded regions of 0.475, which is nothing but your half of your 95%. If you try to search this values 0.475 in the graph, in the values here, you can see here 0.475. see the your row 1.9 and see the column 0.06. Similar, this is first time I will be doing this one. For this 0.475, we have to see the row 1.9 and 0.475, column coming here 0.06. That makes here 1.96. Okay. So the Z is taken here as a 1.96. Similarly, suppose I go for a 80% confidence intervals, divide 80 by 2, is going to come as a 0.4. Right? So what would be the Z for the confidence intervals 80%? Can you see these tables and can you help me to get the answers?
1.29.
1.29. So 1.29 will be going to come as above the 0.40. You have to take one values less, but cannot take one values more. This is going to come here as 1.26. No, 1.28.
28.
Yeah, 1.28 will be taken here as a Z values for the confidence interval of 80%. Okay, but these systems and all already have this calculation with them and all. There already the tables informations are there with them. They will calculate and then give you the values and all. Now, what would be these upper limits? Will this increase or it will decrease if we are reducing this confidence interval from 95% to your 80%? Will these values will reduce or increase?
Increase.
Increase or reduce? Here,
Go higher.
when we going for 95%, in that case, suppose mean is some is there plus 1.96 into standard error. Okay, now it becomes mean plus 1.28. If we keep your mean and standard as errors as constant, so value should be reducing here, no?
Reduce.
So upper limit is going to be reduced. Similarly, in the case of lower limits, what will happen? this also going to reduce. Mean minus 1.96 into standard error, mean minus 1.26 into sorry error. So this is going to reducing the mean values and all. So has a more values, this is going to be having the a lesser values, will be going to become closer to the mean. So both of these values now will come closer to the mean. So this point which is coming here will come to this place somewhere. We will reduce the area, right?
Yeah.
Similarly, from the negative side also, suppose it's coming as minus 1.96 here, so it's going to reduce the area, will come to these regions. So overall the area of your acceptance going to be reduced. So let's see what value is going to come here. Confidence interval 95%. Okay. 80%. So you can see the values here. 80% confidence intervals coming here as a 1.0.
कस्टमर आईडी दे दो, आपके पास वो हम कस्टमर आईडी से लॉगिन करते होंगे, कस्टमर आईडी उसी से खुलेगा।
ठीक है। So here see the alternative hypothesis is coming here as a correlation is greater than 0 and 80% confidence intervals coming here as a 0.7 to 1, that is the maximum values now. Whereas sample correlation will be same, it's not going to change. Now is the sample correlations coming here as above 1 or is coming as below 1? We have to compare these sample correlations values with your higher values of your confidence intervals. Tell me the values. Sipra, can you tell me what is going to happen here?
What is the question?
The question is, we are going to compare the sample correlations with your confidence intervals values.
Okay.
So we have to compare the values with the upper limits. On the basis of that, we have to tell we are going to be accepting the null hypothesis or we are going to be rejecting the null hypothesis. it's coming here not equal to 0, is coming as greater than 0, and p value is coming here as less than say it's quite a small value, e to the power minus 16. So we can say that we are going to be rejecting the null hypothesis and accepting the alternative hypothesis. But when comparing this one, first case we compare with the your 0.05, second case we are going to compare with the 0.2. In both the cases, as the value is very small, it will going to come here as less than 0.05 only. So we can say that your correlation that we are calculating here is greater than 0. So this we are going to be writing it here as a conclusion. The conclusion will be as p value is very less and it is less than 0.05, so we reject null hypothesis and accept alternative hypothesis. At significance level of 0.95, or can say 95%. This is the conclusion for the first one. Second one, that we are doing the confidence level of 0.80. So for 0.80 also it becomes your 0.80 or 80%. Point 0.02 will be like less, no? Looking, see, this should be going to come in terms of confidence and significance level. So together they're going to be have the as 100%. This confidence level. So sum of confidence levels and significance level is going to come as a 1 or say 100%. So here I am taking the 95% coming as a 0.05, 80% so taking as a 0.20. Okay. In the first case we are saying here that correlation is not equal to 0, is not equal to 0, whereas in the second case we are saying correlation is greater than 0. greater than 0. Is fine. Now let's see, suppose I want to do this correlation test but for a specific sex group. In the given data set we have a two sex group, female and male. Suppose I want to do for a specific sex groups. In that case the correlation test we have to change it here. We have to use a tilde symbol to perform the correlation test. Tilde BWT plus SWT, because when we give the tilde symbol then only the subset functions will be used within the core dot test. If you see the
Why plus?
plus, that means between these two variables we are doing it here. Generally when we write a
Earlier we gave comma.
no, comma will be taken as another argument. So when we put a comma it becomes a second argument in the functions. So the first argument must be the variables names which should be we are using for the correlation test. So we have to put both the variables in the after the tilde now. Just like suppose I have to write x equal to y, so can we write x minus y equal to 0? So it is same thing that they are going to doing here. Okay. So tilde BWT plus SWT putting into both into one side and all. Okay. And subset, that is options of a core dot test, and we putting a condition sex equal to f, means the data cats, on this data cats I am applying a subset functions and going to be using for female data sets only, female values only. Over all the correlations values coming here as a 0.80. Let's see for the female what correlation is going to come. For the females correlations coming here as a 0.53, it is less than the overall, and p value is still coming here less than 0.05, so we can say correlation is not equal to 0, it is still true. That is alternative hypothesis is true. And then we have 95% confidence intervals for the population data, 0.28 to 0.71. That means it's going to be varying from your weak to strong. Okay, you can plot this as well. With the plots I'm using so many options here for the giving the names and all. X labs means that is for the x-axis I'm giving a heading as body weight, y-axis headings, and then your chart headings and all. Type equal to n, we are going to put the dot points on the values. Okay, now on this graph the area coming here is a blank areas and all. So we have given the headings, we have given the your y-axis and x-axis headings and all. I am putting these values here. Cat point BWT sex equal to f, SWT sex equal to f, means take the BWT for female and SWT for the female and putting the colors as a red. So you can see the values are coming in the bottom part, that means it has a less correlations. When you put male with a different colors, you will get a blue colors which is going to vary from low to high. So that
What is P?
PCS is options for a different icons. Like you can see here for the female the values coming as a circle, and whereas for the male is coming as a triangle. So PCH, that means to differentiate an icons, the some numbers we have given that using here. So 16 is for the circle and 17 is for the triangle that will be used. Okay, so which has the strong correlations, female or the male? Yes, male going to have the a higher correlations compared to the female. Values are varying from your low to even very high as well. Okay, once we complete your data frames for your analysis and all, you must remove them from the global environments as well. To removing that, we have a functions called rm cats will remove the data frame. So you can see now cat has been removed from the data frames. We have released few RAM memories for the your further process. Now how to perform a correlations between multiple variables? Suppose I have 4 to 5 variables and I want to see the correlations among all the variables. In that scenarios we are going to be performing a what happened? So in that case we are going to be performing a correlations matrix where each variables will be compared with the another variables, and they are going to form a table where we can get the correlations matrix values and all. And for that case I am using here one data set called cement. Cement data set has total 5 variables x1 to x4 and y. It has 5 variables and 13 observations. When we go for the core of cement, I am not specifying any specific variables name. That means I am going to be using all variables of this data frame, one versus other. That means x1 correlation with x2, x1 with x3, x1 with x4 and x1 with y. Similarly they go with x2 as well, x2 with x1, x2 with x3, x2 with x4, x2 with y. Similarly each variables combination they will check and going to give a result to you. You can see this result here. So this result is called as a correlation matrix. To see these results we have to see diagonally the values coming here as 1 representing here that we have strongly correlations for the same variables. That means this values is a correlation among x2 with x2 itself. So to see these results we have to see the bottom part of diagonal. Above the diagonals and below the diagonals both the case values will be same. Always look for the bottom part of the diagonals. This values is giving the correlations between the x2 and x1. Values coming here as less than 0.3, that means it is a weak correlation. Okay, here values coming here x3 and x1 as minus 0.82. What this means, Sipra?
The negative strong correlation.
Yes, it's coming as a negative strong correlations. So x3 and x1 has a strong negative strong correlations. Similarly for these values, Siemens, can you tell me what this means?
This is a strong positive correlation.
Yeah, so x1 has one positive and one negative strong correlations. With x3 it has negative and with y it has a positive correlations. Okay, once we identify these correlations you can go for the correlation test. The only thing that
Yeah. Just learning some stuff.
so when we go for the correlations test we can use only 2 variables. You cannot use more than 2 variables. But correlation matrix can be used with multiple variables. Once we identify which variables has a strong correlations or a negative or positive, you can go with the core dot test to see the p values that its test is significant or not. Okay, covariance is a directly proportional to the correlations. If you see the correlation formula, it is taken as a correlation of xy equal to covariance of xy divided by standard deviation of x into standard deviation of y. That means correlation will be directly proportional to the covariance. So if the covariance comes as high, you will get a strong correlations values. For plotting, you can use these plot functions or can go for the pair. That means one versus other, they're going to plot it. So you can see multiple plots coming it here. You can click on the zoom. By seeing this plot, you can even make a decisions like x2 with x4 is coming as negative correlations, x2 with y is coming as a positive correlations, x4 with y negative correlations. So few diagrams will be quite easy to identify, but few will be difficult to identify. Like in this case, x1 with y, it has positive correlations, but it's not very strong because values are more diversified here. It's not coming on the one line. Okay, so graphically will be difficult to make a decisions. That's the reasons we go for the correlation matrix to make more sure that what relation they are holding and all. Okay. In case we are going to have the rank data and all, for rank data we are going to be using your Spearman or Kendall correlations. For small example I take here, I have a coach 1 and coach 2 informations. Coach 1 has ranked a 10 teams in the order of 1, 2, 3, 4, 5, 10. Coach 2 also has given the ranks, and he has given the rank in a depending upon his criteria and all. So maybe the same team which coach 1 has ranked as 1 may get a different rank by the coach 2. Now I want to see the ranking done by the coach 1 and coach 2 are having any relations or not. That means are these two coaches are judging the team on a same criteria or same parameters or a different parameter they're selecting and all. So for this I am performing these correlations coach 1 coach 2 method equal to a Spearman. Now here you can see I have not used the with functions. Region coach 1 coach 2 are taken as a vector, they are not coming here as a data frame values. If you keep them into data frame, then with functions will be used. So it's giving here a correlation as 0.12, that means it is a weak correlation, means coach 1 parameter of ranking is entirely different from the your coach 2, or say they have no relations among them. Let's see the correlation test and see what going to be having here. Correlation test p values coming here as 0.73, it is more than the 0.05, that means we have to accept the null hypothesis. Null hypothesis say here that correlation is equal to 0, that means no correlations between the coach 1 and coach 2 ranking. If you want to go for Kendall, just put method equal to Kendall and you get the correlations using a Kendall methods. Each of these name that is coming here is based on a scientist name. The scientist who has developed the method to do these calculations, they have given their names to these methods as well. Okay. So whenever ranking data are there, in that case you can going to be using them. You can see in the last I am just removing the your coach 1 coach 2 data values. ls is a function to see what are the different objects present in your workspace, that is in the global environments and all. Depending upon that you can see the values and can drop it in case you want. I want to drop coach 1 coach 2, so rm, that is remove coach 1 coach 2. Okay. Now based on this I have one assignment to do, a case study. I have given a smoking data set to you which is in the form of Excel. So first thing that you have to extract this data, that is a smoking data set. and I have a Word documents as well. So these Word documents you have to read, and accordingly we have to solve the problems given in the files. So two questions are given to here. These two questions you have to solve, and on the basis of your given data, these conclusions that you have to get on the basis of the calculations. Hope you know how to extract the data from the Excel. Yeah, read.xls that you have to use. Okay, so this data is you have to use and have to perform this calculations. Okay, so this much only for today. Next class we are going to be discussing this case, and we go for your regressions. Okay, okay then, see you, bye bye.